Hey, I'm Sebastian. Welcome to this introduction to yFiles for HTML. If you're a web developer working with TypeScript or JavaScript and you're just getting started with yFiles, this video is for you. In this, we'll take a broad, hands-on tour of the library. We'll look at real code snippets, cover the most important concepts you need early on, and show the different parts of the yFiles, how they fit together in practice. We won't go deep into every detail, but the goal is to give you the tools and the knowledge to get productive quickly, including how to use the documentation, the demos, and other resources that come with yFiles. And also how to approach things when you run into questions or issues. So let's dive in. What we'll be looking at today is the following. We'll be looking at the core concepts that make up yFiles. You'll learn about how the API is structured, what patterns we have been using in there, and how to understand and work with the code examples that we gave you, and how you can write your own code. For this, we'll be looking at how to create a simple, basic graph application, very basic from scratch. So we'll be looking at some code in this session, but it's not going too deep. This is really an introductory lesson. While we build this application, we're going to take a look at how to style our elements, how we change the look and the appearance of our nodes and edges in our diagrams, how we configure the user interaction so that the users get the behavior of the application that you envision for them. We'll also take a quick look at automatic layouts, what they are, how you apply them, and what you can do with them. And last but not least, we're going to take a look at the additional material that we provide you with in the package, meaning what demos are there, how you use them, and also what other tools we provide you with so that you can get started with your application really quickly. If you're not new to yFiles, if you have been using yFiles before already, likely that number 6 is the one that you should be looking at. And if this is a recording for you, you can skip it and skip right to number 6. It does contain some new tools that we have been working on lately, so be sure to check that out. So what is the approach? We'll be looking at the big picture first, and then we'll really be looking at some coding examples. We'll check out some code snippets that I have prepared for you, and we'll discuss them, and really on a high level, on a beginner level. So this is for programmers, this is for coders, so you should, but you don't need any prior yFiles experience to attend this. So let's start with the capabilities and the scope of yFiles. What does yFiles actually do? On a high level, yFiles is really for modeling graph data. So this is about nodes and edges, but also what make up a good visualization of a graph, meaning things like labels or groups if you want to nest nodes within each others, but also ports if you want to specifically connect edges not just to a node, but to other things. It's also about visualization, so styling the elements. And for this, specifically for yFiles for HTML, you have the option to go with SVG rendering or with HTML rendering, Canvas, WebGL, and you can even mix them. And so we're going to look at what options you have here. Then we're going to talk about interactive editing. And there's two modes, but basically in yFiles. yFiles allows you to create viewer-centric application, meaning you allow your users to inspect your data, inspect your graphs and diagrams. And also you can allow your users to edit the diagram. So there's basically two modes in there that you can choose from and customize to your requirements. Then of course there's this chapter of automatic layout. One of the big points that make yFiles a great library is that automatic layouts can help you create visualizations from your data quickly and automatically in a way that they will help your users understand the data. yFiles also covers graph analysis algorithms, so you can run analysis algorithms, things like shortest path calculations or clustering or centrality. But we're not going to touch upon that topic today. Just so you know, yFiles also supports graph analysis on the client, meaning this is not a server component, so it's not really about big data. All the data that you want to analyze has to fit into the memory of your client, so you're probably not going to work with billions of elements here. If you want to use larger graphs, do consider our server-side or desktop technologies that you can pair with yFiles for HTML. But typically, these analysis algorithms are meant to be used to help with the visualization and with the automatic layouts for configuring the automatic layouts. Also, yFiles can help you with the data integration. yFiles does not require you to use a certain format. It's just the structure that counts. So as long as your data is in the form of elements and relationships between them, entities, then you can use various tools in yFiles. GraphBuilder is one of them, but also predefined JSON imports, for example. But you can also use programmatic access to create and load your data. So the data integration part is part of the yFiles core capability too. What yFiles isn't, quickly, as I said that before, it's not a backend tool. It runs in the front end, so it's not a graph database. It works well together with graph databases, but it doesn't have to be a graph database. Any data source works. It's also not about the graphs that you know from charting, bars, bar charts, line charts, and pie charts. Even though you can use yFiles to render these types of visualizations, this is mostly interesting when you want to put some of these elements onto your node visualizations. But at its core, yFiles is really about graphs with nodes and edges. It's not a diagramming application. It's a toolkit. It's a developer library for you as a developer to build upon to create great applications for your users. We do have a low-code tool. yFiles is a code tool, so it's really focusing on code. The low-code tool is available on our website. It's called the app generator, and it will scaffold source code in the end for you that you can then run in your yFiles for HTML application. So if you're looking for a low-code solution, check out the app generator. Otherwise, stay with us, and we'll be looking at the code. So as I said before, the layouts and algorithms typically run on the client side, unless you're using a thing like Node.js in the case of yFiles for HTML. They really run on the client side and have to fit in memory. So this is not about big data preprocessing. So let's take a look at the architecture of yFiles and the core concepts behind them. yFiles is a huge library, but at its core, it's mostly one pattern that stands out, and that's the model view controller design pattern, meaning that basically what we have is at the core is the model, the data, and that's in our case is the graph. It's the IGraph interface that implements the model. This is the data structure in memory that holds the nodes, the edges, and as well as the other things that you will find in a diagram like labels, ports, bands, and so on. The model itself will not be visualized. It's just the data. The model will be put into a view, which in our case is the graph component, which is a web component rendering in the browser. And this performs the rendering of the graph and also manages the controller, which is in yFiles are called input modes. And the controller is the part that interprets the user gestures and user input, like mouse input, touch input, or the user pressing some keyboard keys. What happens is that when the controller receives feedback from the user, it will modify the model, the graph, and then the graph will update in the graph component. Any change that you do on the graph will automatically update in the view. That's the usual round trip. So let's take a closer look at these components. The first one is the graph component. It's the view. It's the you typically start with it because it also comes with an instance of the model. It's the main control that handles the display and the interaction with the graph. By default, it uses SVG for rendering the graphs, but also HTML and Canvas and WebGL is supported for larger graphs. Basically, what the graph component holds is the state of the view, meaning things like where you have been panning, whether you zoomed into, that state that's held on the graph component. It's being held in the graph component. So even though a graph can be in multiple views, each view can have its own zoom or panning position and so on. So a graph component has as its key properties the model, which is the graph, and also the selection, which is kind of like a model, but it's separate from the graph because you have kind of different selections. It has the input mode, which is the controller, and things like zoom and so on. Then we have the model, which is the graph itself. It contains the data, and it also serves as a factory for you as a programmer to create the elements, to populate the model. There's methods on the graph like create node, create edge, add label, add port, or add band, which populate the graph. And there's also methods that will modify the elements on the graph. But these are the most important ones, obviously, for creating the graph. The graph itself uses objects, meaning that you don't pass in reference IDs, no strings or whatsoever. Instead, when you create an object, when you call the graph create node method, you get back an object, a reference that describes the node, and which you can use to query about its properties and modify. And you also pass it back into the API whenever you need to work with a node or an edge and so on. This is much easier than using string IDs or numeric IDs because you don't need to do the bookkeeping. It's always type safe, and you will never get any duplicates. The only problem is, or the only disadvantage to string IDs is that if it's about serialization, obviously you can't easily serialize references because then you need to do the mapping between the elements in the memory to the values in your database if they need something like IDs. Not every database needs an ID. But you can forget all the hassle while you're working with the graph and only care about the IDs if you need them at all during serialization and deserialization. Being the model, the graph is also observable, means it can notify the view and other parts of the application of changes. Whenever there's a change in the graph, it will raise an event, and from the event data, you can the observer can understand the change and react accordingly. In the simple case, when there's a change, the view, for example, will automatically update the view, and you will always get the live view whenever you make a change to the graph. Taking a closer look at the elements that make up a graph. These are mostly, as I said before, the node, the edge, but there's also labels and ports and bands. So let's go through all of them. There's this visualization at the bottom where you see most of these items. The orange ones are the nodes. Nodes, they have a layout. A layout is the geometric description of where the node is logically located. Meaning this is just basically a rectangle with X, Y, with width and height. It's the style which basically has the job of taking the layout and the information in the style and creating a rendering, a visualization of it. So a node can have a different style and then it will appear differently on the screen. A node can also have any number of labels. Labels is typically a textual description on top or next to the label, next to the node, but could also be something like an icon or an adorner. Nodes can also have ports. While this port-centric model that we use in yFiles is not always required, it's helpful in many situations where you actually need to model connections from an edge to a node with respect to different ports. So one node could have multiple ports, and each port can have 0 or more edges connected to it. If you don't care about ports in your application, you can basically simply ignore them. There's overloads in the API that will make the existence of ports for you basically transparent. But yFiles will automatically add and remove ports in that case for you. So edges, as I said, they connect to ports. They are called source port and target port. So an edge is, at its core, is a directed. It has the notion of a source end and a target end, but it's up to the visualization, up to the style, and up to the algorithms how to interpret that. So if an edge is actually an undirected edge, meaning that it doesn't really have a direction going from one node to the other or the other way around, at the code level, at the memory level, it always has a clear source and target end, but it's up to visualization, whether to show that to the user or up to the configuration of the layer algorithm, whether to actually do something with that information. Also, edges, just like nodes, can have any number of labels, and they can also have bands. Bands are additional control points that that describe the geometry of an edge. But it's the job of the style to interpret this geometric information. So whether it's a straight line or whether it's a curve, that's the job of the style implementation. The same is for the labels. Labels basically consist of a layout, which is the rectangle, which is oriented in space, so they could have any orientation. In this case, the gray rectangle over there. And the style renders the text into the label. A label also has a property text because that's rather common for a label to actually contain text. And ports can be rendered in the screen like we have them here, those black little dots, but they don't need to be. Typically, if your application doesn't care about ports, you won't see them at all. And if your application is port-centric, ports can also have any number of labels. So like we see, the blue one in this visualization could also be a port label. There's one thing I omitted in this. There's two things I omitted. Let's first look at this one. As I said before, edges connect to ports, but edges can also have ports on themselves. Not the ones that they connect to, but where other edges can connect to. And this allows you to model create edge-to-edge connections or edge-to-node connections, like in this example over here. So these two edges also have a port at the center, and there's another edge going from the one port to the other node and to the other port at the other edge. Also, nodes can be nested, as I said before. This means they can have an optional parent property, or at the reverse, nodes can have children. Like in this case, the blue one is a bigger parent node, which has two children, the 1 and 2 node. So when you create those nodes, you can specify that they will be part of certain groups. So this is not just a visualization, but the core data structure knows that they are related to each other, and one is a child and parent relationship. And there's arbitrary nesting depth, so it doesn't have to be just one level of parents. It could be any number of parents. So let's take a look at the tag property that you saw in that slide before. What's that? Every graph element in our graph data structure has an optional tag property. That tag property is meant to be used by you, the programmer. And yFiles doesn't really do anything with it other than allows you to store it with the graph. You can use it to store the business object that is associated with the given diagram element, if any. For example, if your data describes a set of persons, and you have something like a person object in your application already, you would probably put that person object to the node that represents that person. Why is that useful? This is anywhere in the API where you get a reference to one of these elements, you can go to that tag and directly get the associated object with it. For example, in this case, where we're creating a node and we are telling it that the tag is this piece of data, which is pretty boring in this case. But this means that after this, if you take a look at the node, the tag property has this data associated with it. And for example, if later on in the code you have an event listener, and we get to see how this works later on, that is called when the user clicks on a node, you can check the property of the item that has been clicked and directly get the object that is associated with the item that the user interacted with. And then you can do the needful thing and do the special handling depending on the tag and so on. So this is helpful for doing data binding, but also for making decisions for interactivity or for configuring the automatic layouts later on. if we are using the GraphBuilder class that we're going to take a look later on, tags are being automatically assigned from your data to the elements. But more on that later. First, a quick look at the input modes. I told you about these before. So there's basically two modes that you have. By default, you can have any other number of modes, of course, but these are the ones that are available by default that you can configure to your liking. And one is for really editing the graph, where you can create elements, move them around, resize them, use the clipboard, undo functionality, and so on. And the other one is mostly for a read-only viewing. This doesn't mean that the graph is static. For example, if the data that you're rendering on the screen comes from some live data source, it could happen that the data updates, but it's not through direct interactions with the user. So the user is not like clicking to create an element, but rather the element creation happens through another means. Both of these modes are highly configurable, so you can really configure them to match your requirements, so that you can optimize them for the user stories that your users will go through when they work with your graph. Over here, you can see choosing between those modes is easy. Just instantiate one of these instances and assign it to your graph component. So this is the big picture of how a typical graph application works. We start by loading the data from our data source and getting it to the front end, to the browser. So how that works is really up to you, whether you're connecting to some REST endpoint or doing some WebSocket connection and parsing some binary data or whatever. First, you need to get the data to the client. And on the client side, in the client library with yFiles, you transform it into a graph. How this works, we're going to see in the next steps. Then we're going to apply some styling so that the elements look nice and show exactly the information that we want them to show. Then we can apply an automatic layout so that the elements actually arrange neatly on the screen. And we configure a user interaction so that the user can actually work with the graph, be it just navigating around or really editing the graph or changing it. And typically, once you have user interaction in place, what happens is that you're for example, going back to the previous stages where when the user clicks a button, it can happen that you get new data incrementally from the server, transform it into a graph, again, do the styling and reapplying the layout, doing incremental changes to your graph. Any backward feedback loop could be incorporated from that. But before we take a look at actual code examples, let's quickly go through some of the API patterns that we have applied when we wrote this API. The yFiles API is very huge. It has lots and lots of elements, but we tried really hard to make it very consistent, to apply the same patterns everywhere. So once you've seen one part of the library, it should be pretty easy to understand other parts, because they work the same. They use the same patterns, they use the same mechanics, and so on. Let's take a look at these patterns that you will frequently see when you work with yFiles. So, as I said before, yFiles is mostly an object-oriented programming paradigm. But it does have a lot of functional enhancements. But at its core, you're working with objects, with instances of classes. And these are typically they feel like regular TypeScript or ECMAScript 6 classes, and you can use the class keyword and the extends keyword, for example, to implement or extend existing classes. So typically you will do something like new graph component to create the graph component. So these are classes, and there's hierarchies and lots of instances. Classes also help you with namespacing, meaning if there's certain properties, you will even like enumerations, they serve as containers, as namespaces for the values. A typical example is an enumeration where you would import the enumeration, and then the members of that enumeration are the actual values. We also have interfaces. That's not typically the kind of interface that you know from TypeScript. These are slightly more advanced. You will recognize interfaces because they're all prefixed with an I for interface, like iNode in this example over here. So this is an interface for a node. And you don't, in this case, you don't care about the actual class, and there could be multiple implementations behind that. But this is not just a type, like a TypeScript type. In fact, those are actually namespaces and container objects, meaning you can do things like instance of. You can do if item instance of inode, and that will compile and work at runtime. It's not just a TypeScript type. This is because yFiles interfaces are actually mixed ends. They can carry additional functionality, and if you implement one of these interfaces, one or more interfaces, they can actually get more members and default implementations mixed in. We'll see that later on. This also means that many of these interfaces can have static members, meaning you can do inode dot something, and because there may be some statics, some constants declared on the interfaces. This also helps with the structuring of the API. So you have very few top-level functions or values. Most of the values and functions are part of classes, interfaces, or enumerations. Those classes then obviously have things like properties, fields, or methods, and they use the typical object-oriented concepts of being like sometimes being read-only, being protected, meaning that you should only be using them as a subclass, or they can be final, meaning that you shouldn't be overriding them, or they can be static, meaning that you don't need an instance to access them. So very object-oriented. Sounds old school, but really makes it easy to work with a library because of the complexity. If you customize your object in yFiles, there's basically these different options that you have, and they are in ascending order of complexity. The most basic version that you have is that you create an instance and then you configure it by setting another property. So objects have properties, and you can reconfigure those values if you don't like the default values. That's the most common customization that you will do in yFiles. Second most common is probably something like, if you want to react to something happening, is that you will be registering event listeners, meaning callbacks that will be invoked when something happens. Only then you will use the old school subclassing mechanisms. If that's not enough, if you really want to like customize the behavior of an object to a very high degree, you can optionally subclass classes, and this works just like you would do in TypeScript. You just use the extends keyword and then override a method and change its behavior. Last but not least, and this is really expert, is sometimes you have to implement your own interfaces or implement one of our interfaces with your own implementation. And this works because of the mix-in nature of interfaces. You can't just use the implements clause, you will use the extends clause. You will extend from a base class which implements one or more interfaces, but we'll see that in another slide. First, we'll take a look at the most frequent pattern in yFiles is when you do function calling, when you invoke methods, constructors. Obviously, the default is in yFiles is that parameters that you need to pass to functions are positional parameters, meaning that you just provide all the parameters separated with a comma. But parameters in many cases can have default values, then you can simply omit them. Like in this case, we have the create node call, but this is actually takes a rectangle, which is the layout, then the style, and then the tag. And you can omit all of these because there's defaults supplied for these values. For more complex signatures, you can actually use named option parameters. That is, you are passing in objects, a JavaScript object. You see here the curly brace. And they take an object which have key value pairs, and the keys are typically exactly the names of the parameters of the function, and the values are the values. The advantage is that obviously if you only want to supply a few of the parameters, but not all of them, this way you can just skip a certain parameter, for example, not specify the style. There's something interesting happening here too. If you use the options parameter, some of these methods allow specifying additional options, like in this case, the labels option, which is not available if you use the regular positional parameters, because this is basically equivalent to the above call, where after the creation of the node, we also call the add label method. And so you can pass an array with multiple labels, and then multiple add label calls will be done. So this is just a shorthand and not super important, but if you come across it, this is what happens behind the scenes. Also, what you will see is that since yFiles uses basically objects everywhere at its core to supply you with utility functions, utility and type safety and stuff like that, sometimes things can get a little verbose with the core data types, like in this case with the rectangle. So specifying a rectangle by instantiating a new instance seems very verbose, or is very verbose. And so for many of those simple data types, we support what we call auto-conversion, meaning that when you pass in the values to yFiles, you can use a shorthand. In this case, for a rectangle, you can use a number array with 4 values for x, y, width, and height. And yFiles will automatically convert this to a rectangle, meaning that the node that gets created does have a rectangle associated with it. So if you query the value afterwards, you will get back an actual rectangle, but you passed in just this this shorthand object, basically. It's the very same thing when you create objects. So when you call a constructor, it's basically like function calling. If you create an object, what you can do is create the object and then assign the properties. Alternatively, for most of the properties, those that are read-write, you can also specify a named option argument in the constructor, and the properties, the names of the keys in the option map to the properties. So these two calls are equivalent in that they will create a style instance which has a stroke in the target arrow assigned. And again, this syntax allows you to use shorthands. In this case, for stroke, which is an object, there's also the option to use the CSS shorthand that you may know from HTML to specify a stroke. So 1 pixel black actually results in a stroke object with a color of black and a thickness of 1 at the end. And this automatic conversion actually also works with property setters. So at the moment that you set a property on an instance, you can also use these shorthands. But as immediately after you get back the value, it will already be converted. So it's not the string none anymore, but it's in this case the instance, the constant that is defined on i_arrow.none. A few more words on auto-conversion, some examples that you see that this is actually useful. For example, we have the option to specify a time span, which is the duration for in this case, for a layout animation. This is actually an object because it's not just a number, because then you don't know whether it's seconds or milliseconds, and you can't do arithmetics easily on it or do comparisons. Well, in the case of a number that would work, but with other cases it wouldn't. So this is an object, but it's more convenient to just write the string 3s, 3 seconds, than doing the time span dot from seconds over here. For all of these conversions, there's also the convenience. If you go to the type, there's a .from method, which you can pass in those substitutions, and it will immediately give you back the actual object. So the result of calling timespan from 3 seconds is that you get actually an object of type timespan. And this is what happens internally in yFiles. Very frequently, we will see this pattern with enumerations. So enumerations are typically constants defined on namespaces, like in this case, the shape nodes shape, but you don't have to pass in this longish expression here, you can just pass in the string and your IDE will automatically complete it for you. And this will automatically convert to the respective object. Okay. So I touched upon this briefly before. Events are really important in yFiles because they connect the view to the model to the view, but they also allow you to react to changes in the model or to react to user-driven changes. So those elements that support those classes, those objects that support events, they have this DOM style add event listener and remove event listener method. So you could, on Graph, there is this method that you can just call, and then it works just like you know it from the JavaScript DOM. You pass in the name of an event, a string constant. For example, that will be node created or edge removed, label text changed, and so on. And then the second parameter is the function that gets called when the event happens. And just like in the DOM, there's actually a third optional parameter that you can use. It accepts a once property, which you can specify to true, which would be the non-default, which means that you only get notified once, and then this listener will get automatically removed from the event source. Also, you can pass in a signal from an abort controller, and once that signal triggers, automatically the event listener will be unregistered. Of course, you can do it just the same manually by invoking remove event listener, but then you have to make sure to pass in the same reference. You can use these events to sync the state in yFiles with your application state, be it with your UI model framework. For example, when someone clicked something and the selection changed, you can show a detail view, but you can also use that to synchronize it with your secondary data storage or your primary data storage and write back changes to your database. You will come across collections frequently in yFiles. yFiles is full of collections. A graph consists of a collection of nodes. Nodes have a collection of labels. Edges have a collection of bands, and so on. So there is this interface, IEnumerable. Some may recall this from the C# world, where it has the same name and it works the same. And this is actually an interface that is a live collection, very similar to what a very modern ECMAScript has with the iterable interface, meaning that this is not the data itself, but it's a contract that allows you to query the data. So these are live collections, meaning that if you change them and reevaluate them, you get different values. Unlike, for example, an array in JavaScript, where when you apply the filter operation or the map operation, this happens immediately, and then you have a copy of the data. Whereas in yFiles, those enumerations are live. They don't happen until you enumerate them. And enumeration happens, for example, when you call reduce or for each on them. So enumerations have a lot of utility methods that you can use to work with the collections. Like, let's take a look at some of these. For example, to get the first node in a graph, you use the add method. And most of these methods are very similar to the ones, or identically to the ones that you find on array or the modern iterable method. Just that they always work on an IEnumerable and are actually live. There's also utilities for finding elements, for filtering elements to create a filtered collection, for mapping a collection to another collection with different values, doing MapReduce functionality for each, and many, many more. If you want to actually materialize this and don't want this to be a live collection, you can call the toArray method or the toList method, which actually creates a copy of the values. That's, for example, very important if you want to remove a number of elements in the graph and you iterate over those elements. You shouldn't be calling remove on those elements, because while you're doing this, you're modifying the collection that you're currently iterating. And so what you should do instead is first create a copy of all the elements that you need to delete and then remove all of them. But that's not something that you will probably do very often. yFiles is very consistent regarding its naming. I told you about the I prefix for all the interface names already. So if you have a node style, it implements the I node style interface, and typically concrete classes don't have the leading I anymore. Many abstract classes use base as a suffix, meaning that those are meant to be used for you as a base for overriding. For example, if you implement your own node style, you would extend from node style base, which implements the I node style interface. So there's a very rigid naming strategy here, and this will help you understand and find the corresponding classes and interfaces quickly. Constants are all uppercase, like in iArrow.none. And we've seen that there's enumerations in namespaces, and the names of the namespaces indicate whether these enumerations can possibly be combined as bitwise combinations. Then if so, they will be in plural form, like in this example. So if there's an enumeration called graph item types, and the values, edge and node, can be combined using the bitwise combination. So these are basically numbers. And you see that you can do this because the container type is in plural form. And another naming convention is event names. We've seen these names before when you use the add event listener method. The names of the events indicate or tell you more about the timing of these events. When it's drag starting, they happen before the actual drag start, and when it's drag started, they happen after something happened. So just look at the time, if it's the ing form or the ed, and you know it's happening before or after the event. Okay, now back to the interfaces. How does it work? That's really the advanced topic. If you want to use interfaces and implement your custom implementations of certain interfaces, this is how it works. You're probably not going to use this example. That's just as an example. But here's how it works. Imagine you want to implement a class that both implements the iPoint and the iSize interface, which are actual interfaces in yFiles. The point interface has X and Y, and the size interface has width and height. And this is how you would create a class that implements both of these interfaces. What you write class in the class name, and then the extends clause, use the base class, which is one of those few top-level functions that you can import from yFiles, and pass it the base class, if any, and then all the interfaces that you want to implement. Then when you instantiate an instance, this instance is actually an instance of your class, and it's also an instance of iPoint, and it's also an instance of iSize. And because interfaces are mixed-ins, you can also use the mixed-in methods and properties of those interfaces. Like distance to is a convenience method that is available on point, and isEmpty is a convenience property that is available on size. So interfaces work like mix-ins, and they can have non-virtual members that you don't need to implement, like distance to or isEmpty. You just get them for free. Also, of course, they support static members as a namespace. Okay, now finally, let's get our hands on and see how we create a graph. It's actually a lot easier than the stuff that we talked about already. So in this very simple example, I'm going to build a graph like this. So it's just a few nodes and an edge and a label, and that's it. So how do we do that? Really, step one is you need an HTML file that contains an element which hosts the graph component. Basically, the graph component is mounted onto that element, just like like you know it from like React. So like the application root element in React. So what you need to do is declare or get some div into your DOM somewhere, and then you need to be able to identify that div, and you call the graph component constructor and pass in the selector, the CSS selector that specifies the div. You can also or simply pass in the reference if you happen to have it lying around. And this mounts the graph component onto the div. And when you do this, you will see basically nothing because the graph is empty. So this is just an empty white rectangle unless you style it differently. Next thing you probably do is you obtain a reference to the graph, and then you can populate the graph, call create node, or alternatively set an input mode like the graph editor input mode. And once you do this, this will already allow you to just click the mouse inside the div and nodes will start to appear. So that's the very, very basic thing, the only thing that you need to do to get started with yFiles. Now, how do you create a node? We saw the method on graph already, which is called create node. And now we're using this long form over here where we are specifying manually the layout, the location of the node, X, Y, width, and height. We also assign it a style, in this case, a shape node style, which is a style that is available out of the box in yFiles, which is just a rectangle if you use it like this with a nice fill, the color. And we also assign it a tag, in this case, the data that we associate with the node. Alternatively, we could have just called create node or these variants over here. Next step is once we have our nodes, we call create edge on the graph and to connect two nodes. As I told you before, you typically actually edges connect to ports, but you can just use the create edge overload that accepts two nodes. So you can call graph create edge and directly pass the references to the nodes that you created before. In this case, the CEO node and the CTO node, and this will create an edge and add it to the graph. Once we have the reference to the edge, we can also call add bend to add another bend to this edge. Alternatively, we could have also supplied the edge with a custom styling. Like in this case, we specify a different arrow, the size, the form, and the color of it, as well as a stroke for the line. And if you're dealing with ports, you can also work with the ports. If there's a port already declared, you can get the first port, for example, from one of the nodes, or add a port to another node and then create an edge between those. So this is how you connect nodes. Last but not least, you probably want your users to understand what they see on the screen. So you can add a label like a text to the various owners. And that's as easy as calling add label, passing in the reference of the object where you want to add a label, and then pass in the string. Again, the long form allows you to specify the owner, the text that you want the style to render, and then the actual style. And the style, in this case, we only specify the font that we want to be used, but we could also do things like specify the background color, whether there's a shape around it, whether there's an icon associated with it, and so on. Last but not least, when you add a label, you also need to tell it where to place that label. And that's where we, in yFiles, we use layout models. These are different small pieces of code that dynamically determine the placement of the respective labels with respect to their owners. Meaning for nodes, typically you have like a placement below, on top of the node, right across diagonally at the node, or somewhere else. Whereas for the edge, they could be at the first segment, second segment, at the center, and so on. And the parameter is basically like a strategy where to place those items. So you don't have to specify the exact coordinates, but you tell it where to logically place those elements. This has the advantage that when once you change the position of the nodes, or change the size of a node, or change the positions of the bends in an edge, that the labels will automatically stick to their places, and they will stick to their model, to the implementation of their model this way. So for placing labels at their owners, you need to choose one of the various models that basically calculate the placement of the items. You will find all of these in the documentation, which I'll show you later on. Last but not least, position the graph in the viewport. You might not know how large the screen is of your user that the user is using, or you might not even have coordinates. So what you should be doing is trying to put the graph onto the screen. The easiest way is to just call the method fit graph bounds, which automatically finds a tight bounding box and centers that bounding box on the screen. You can also do this manually if you want to. You simply specify the zoom point, which is the zoom value, which is basically the scaling of the graph on the screen, and the viewpoint, which is the location that you want to have at the top left of your graph component in the graph coordinate system. And also, you should not forget to if you go the manual way, only then you should also specify the bounds of the contents, so that when there's scroll bars, that they know how far they should be going, how far should the user be able to drag or pan around. Alternatively, if you don't have any coordinates assigned previously, you can just apply an automatic layout, like in the last example over here, and this will automatically morph the animation and center the graph in the center of the screen of the component by default. Speaking of defaults, you don't always have to specify for each and every node and edge what style to use. Instead, there's this property on Graph which is called node defaults, and there's also a property called edge defaults. But on these, you can specify properties like the style or the size, and then pass in an object. And these will be used whenever you don't specify the style explicitly. So if you, as I told you before, that there's optional parameters. So, and if you omit these parameters and don't specify a value, the defaults will be used instead. So this happens at creation time. So meaning that at the moment you call create node, the defaults are fetched, but this doesn't happen retroactively. So if you're changing the defaults after you created the graph will not change. So this is not like a CSS style sheet. This is just the defaults that will be applied the moment the items are created. This also applies, for example, when you let the user interactively create an element, because obviously then no code runs, and yFiles needs to know what style to apply, and it will fall back to the defaults unless you do another customization. So this helps you to reduce the amount of code and unclutters and separates your graph creation logic from your styling logic, for example. So how do we get the data to the graph? Right now we've seen how to create one node and one edge, so that's easy. But typically we don't have a hard-coded graph, but we have some data that we want to map to a diagram. For example, consider this case. We have some data structure that we might have gotten this from a JSON file or from an API endpoint, which is basically an array of objects where there's they might have IDs and a property like name and some other properties. So what you can do, the easiest thing that you can do is you simply iterate your data. In this case, this is an array, so I can use just the for each method. And for each of the data object, I create a node and pass in the tag, the object as a tag. This is not actually not necessary, but helpful later on. This will create a new node. What you should be doing then is remembering that this object, or in this case, the ID that you associate with this object, is associated with the actual instance. Because what you will then do in the second step is that you will basically do another looping, and you iterate over all of the connections in your graph. For example, in this case, the connections are created implicitly. Like in this case, the CTO reports to one, which is the ID number one, the CEO. And so what we will do is we will again iterate over the data, basically find any method that will iterate you or enumerate you all the edges, the relationships that you have in your graph. Then from the data that you have, get the corresponding nodes, in this case by looking up the IDs in your map, which is just a regular ES6 map, JavaScript map, and call the createEdge method. And this way you can create graphs of any size without hard coding them. The recommended approach, however, is slightly different. There's a utility class, and it's really just a utility class, which at the core is using the very same methods that we just saw, is the class GraphBuilder. And that's the recommended way. It supports a more declarative way of converting your data to a graph. and it allows you to declaratively specify bindings from your data, for example, to the visualization. Let's take a look at how this works. Again, we start with the data that we get from somewhere. In this case, it's just hard-coded, just for this example. We instantiate a graph builder and tell it what graph instance to populate. So the graph builder will go and add elements to this graph instance. And when you get that graph instance from a graph component, it will immediately appear on the screen. Then what you need to do at least to get something useful is to tell the graph builder where to find the nodes. And in this case, I'm telling it to look at the employees and check out the ID property. So I'm passing in a Lambda function over here, which gets evaluated by yFiles, and yFiles does all the ID bookkeeping for you. This is necessary because in the next step, you're also going to pass all the edges into, or the objects that represent edges, and then tell it where to find the source ID and the target ID. So again, we're using simple lambdas here, and TypeScript will make this type safe for you, so you can actually do code completion here. And then finally, when you call the build graph method on the instance, yFiles will actually do the iteration for you. This doesn't sound terribly convenient so far, but we'll quickly see why this is helpful. That last point here is crucial. For example, if you have incremental changes in your data, you can simply change your data source, add more objects to your employees array above here, and simply call update graph again, and then yFiles will automatically apply the change and add the new elements, remove old ones, while keeping the changes that you did or that your users did with the previous iteration of the graph. What's also helpful is data binding. When you create these node sources, in this case, you get back an object which has this property called node creator in the case of node sources. And for the node creator, you can specify what style to use. And this means that if you have different node sources, for example, you have different arrays, one with the employees and one with the buildings or teams, you can always use the same pattern. You create different node sources, for each declare the ID mapping, and then you can customize the node creator for each of these node sources and declare how they should be rendered. yFiles will automatically mix and match them to the various elements. Also, using the node source, and exactly the same works with the edge source too, you can specify how to create labels for your elements just by specifying a label binding. And in its simplest form, you just declare how to get from your data to the textual label, and yFiles will do the rest. You can also use this to modify the style. For example, if your style has a property fill, like we've seen before, using this method, you can declaratively change the fill of the items created using the GraphBuilder. The same works for layout and other properties, just the same. So to summarize, the GraphBuilder is basically used for you so that you can tell it where the data is. You pass it the data and explain to it how the data should be interpreted. So how the nodes and relationships and the labels are structured in your data. This means you don't have to adjust your data to a certain pattern, but using this technique, you can basically use any data source that has nodes and edges. If you're going this way, nodes actually need to have IDs because obviously yFiles needs to reference them, but IDs could be just the objects in case you actually have objects already. The ID provider that we saw extracts the ID from each of the items and then performs the mapping for you. There's node source and edge source. One creates nodes from a collection of data items, and one creates edges from a collection. And there's also recursively defined, there's a source for labels, so that for each node and edge, you can also add labels. And it's important to say that you can have multiple of them, and some of them can be specifically configured to create group nodes, for example, or have multiple different types of nodes or edges. And crucially about this one is that the GraphBuilder will always automatically attach the data object that it used to create the various elements in the tag property. Last but not least, I hinted at this before. One of the advantages of using GraphBuilder is that it also helps you with updating. So if you update your data, for example, if there's new data coming in from the server, you just change the values in employees, and then you can call update graph, and it will perform the necessary changes. Once you do this, you should probably apply another layout because likely the layout doesn't fit anymore with the new elements coming in unless your data already has coordinates applied. It's important to understand that the GraphBuilder does not automatically apply a layout. It's up to you to configure or launch the layout. So typically after an update graph or build graph, you will run a layout algorithm like in this example. There's other graph builders. I won't go into too much details. There's the one that works with trees. Specifically, if each node knows its children, then there's a simpler version of Tree Builder. And there's also a more complex one that works with more complex structures where, for example, nodes know their incident edges and edges know their incident nodes. And the Graph Builder, you can configure it that way to also quickly create graphs from this information. Now let's take a look at how to style items. Styling is important because styling helps your users better understand your graphs, and it makes your diagrams unique. It makes them hopefully look professional and polished, and they help you with your brand consistency if it's a customer-facing, end-user-facing diagram that you're creating. But most importantly, styling helps conveying the information that you need to be conveyed. So styling can help you show certain aspects in the data right on the screen without the user having to, for example, check the details of an item. yFiles comes with a lot of different built-in style options for nodes, obviously, which is the most frequent customization that you will do. There's tons of different simple geometric shapes that you can use, predefined ones, but there's also the option to have a generic geometric shape where you specify a user-defined geometry, for example, in this so-called general path node style, where you can create shapes like this cloud, for example, programmatically. But there's other styles which are optimized for displaying images, or which look like an arrow over here. And there's also a predefined group node style, which can be configured to look like a container node that users can open, expand, and collapse. But that's not all. Obviously, for many use cases, you need real custom styles, and that's what you can do with yFiles. You can implement your own styles that are either using SVG for the rendering, or Canvas if you want to, or HTML-based, specifically if you're looking for lots of text rendering. That might be interesting. And you can use UI templating, meaning that you can use other technologies for actually creating HTML DOM, or for rendering into a canvas, for example, to use this for the visualization of your items. For example, you can use React or AngularJS or Vue.js to render the SVG DOM or HTML DOM for a specific node. And there's also convenience classes that we have. One is called composite node style, and the other one is delegating node style. They are classes for you to build upon and to combine multiple styles together and then create new ones. But I'm not going too much into detail here. There's a whole tutorial available showing you how to use these. There's demos showing each of these different styles, and you will find a lot of information about this in the documentation too. Just so that you know, you have the option to use one of the predefined ones, and also build your own ones. The same is true for edge styles. There's a number of edge styles built in, most prominently the polyline edge styles, which is basically just a line connecting the bends, optionally with some arrowheads at the end and the start, and maybe some smoothing at the bend points. There's also a Bezier edge style if you want more smooth curves, or this arc one, which was just a single arc always. There's this bridge style over here, and this slightly differently looking style, which looks like one big arrow, for example. But again, you can create your custom style, and you can use SVG, then use CSS styling and transitions and animations to animate your styles, or even animate the existing ones just by specifying an additional CSS class. And again, we have the composite edge style and the delegating edge style for you to build upon. Last but not least, I'm going to quickly show you the label style. There's basically 3 interesting label styles predefined. One is just the one that renders text on some optional background within the shape, and you can do some alignment and shape wrapping and so on. But it's basically just text in the form of, in simplest form, unstyled text. In contrast to this, there's markup label style, which is a rich text style, which is like a subset of HTML-like markup, because this is actually rendered in SVG. If you want to render HTML, use an HTML-based label style. This is using SVG. Icon label style adds icons to a label, and you can any number of icons this way. Again, you can do custom styles or use the predefined helper classes. Now let's quickly take a look at interaction. Why is interaction important? Well, there's obviously very different use cases for diagramming. There's, for example, things like dashboard, like we have here on the left-hand side, where it's mostly about viewing the data or just watching it or maybe searching it. And then there's whole applications where you move elements around, edit graphs, and let the user build diagrams. And there can be specialized tools that really come with a very bespoke interface. And for all of these, different user gestures should be applied. And I mentioned these before. There's mostly Graph View input mode and Graph Editor input mode, and where Graph Editor input mode is mostly a superset of what Graph View input mode can do. And that would be navigating, selecting items, displaying tooltips and context menus. But there's no modification built in, like creating elements, deleting them, so on. Graph Editor also allows you advanced stuff like doing undo, redo, copy, paste, drag and drop operations, anything that you can imagine, basically. There's also things like snapping and assisted drawing and constructing of elements. So this is how it works. You instantiate a new instance of the respective input mode. Then you optionally reconfigure it to your liking. So if you don't want the user to dynamically create nodes, you can disable this for the editor input mode, even though it's editing. Or you can use event listers to react to changes that are user triggered, which is different than changes that are triggered by the model. Because, for example, if the user creates a node and then undoes the creation by pressing the undo button, the model will fire the event that a node has been removed, but it's not something that the user triggered, because if you redo the creation, the model will tell you that a node was created, the old one that was just deleted, but that is not a user-initiated gesture. So these events on the input mode only fire for the user-initiated gestures, and that's a huge important difference. And it depends on what you want to do, whether you want to listen on the low-level events on the model or in the controller. Most of the time, you probably should be looking at the events on the controller, unless you're really doing low-level data synchronization. Those input modes allow fine-grained customizations. For example, here I'm disallowing the creation of self loops, which is a sub input mode available on Graph Editor input mode. There's many more, like for the resize handles, for moving elements around, for moving unselected elements around, for adding bends, and so on. And you can configure these to your likings. For example, which mouse buttons need to be pressed, or which keyboard shortcuts you should hold or press when you're doing certain operations. And this can all be done on the various input modes. Now, automatic layout. Why should we be using automatic layout? Well, as we've seen before, sometimes our data doesn't have this information, or most of the time, the data that you have won't have this information. No location information will be associated with the items. And then if there's a lot of items, you don't want you don't want your users to move those elements manually into position. Instead, you want to apply an automatic layout that will automatically determine the locations, or the best locations for the elements on the screen. When doing so, you can configure the automatic layouts to highlight certain aspects in your data, so that it's easier for your end users to understand what's happening in your data. So layouts is not just, the purpose is not just for the items to become visible on the screen, but to actually highlight certain aspects in your data. For example, if there's a flow in your data, that things going from left to right, then the layout will automatically place elements in this order, if you configure it to do so. But sometimes other aspects are more important, and then you can choose a different layout that highlights those aspects. I'm not going into details what aspects the various layouts specifically highlight. Just be aware that there are many different layouts, and they have different use cases. So depending on the type of data that you have and the semantics of your data in your graph, you should be looking at different layout algorithms and different configurations of the layout algorithms. So these are just a few of the many different layout algorithms that yFiles has. Applying a layout is pretty simple. It's something that you need to explicitly invoke. yFiles will typically not by itself apply a layout. Instead, you either apply the layout on a graph. There's this method called .applyLayout, and you pass in an instance of a layout algorithm, or you can use this method on the view, on the graph component. which allows you to animate this change. So this will automatically come up with a nice morphing application. It will first apply the layout passed in, and then show this in a neatly animated fashion. Layouts can, you don't need any coordinates initially, but you can, most layouts will just go and come up with coordinates, but some of them can also work incrementally. So if your data changes over time, they can use the current state of the diagram and incrementally add additional elements to them in the process of what we call incremental layout. This helps users keep their mental map of the diagram. When they've been working with the diagram for a while and then new data comes in and the whole diagram changes, that's a bad user experience. If you do an incremental layout, only a small necessary changes will be made. For configuring the layout, basically works the same as with all other objects in yFiles. So you construct a new instance of the layout that you've chosen, and then specify the various properties and configure them to your liking. Here's just an example. For example, you can specify the orientation for the hierarchical layout, whether it's going to left to right, top to bottom, and so on. So first step is to configure the automatic layout, and then if you need to, you can also specify the animation, which of course has things like the duration. So if you wanted to animate slowly, you can use larger numbers over here, but you can also do things like prevent the camera from moving when something changes, or even anchor items in inside the view so that they stay at a certain location. For example, if the user clicks on an item and expands, you want that item to stay fixed. There's many more options, but I'm not going into these details. This is just the overall concept. Another very important concept is when it comes to layout configuration is that you may want to specify a configuration per item in your graph. So some items in your graph should be treated specially in the layout. For example, sometimes the items in a graph can have a different semantic meaning, and you want them to be clustered together, but the algorithm doesn't know that they have a semantic meaning, so you need to provide that information to the algorithm. And here's how that works. Typically what you have is when you've chosen a layout algorithm, you instantiate an additional class which has the same name as the layout algorithm, and with the data suffix applied. That's always the case. And this one is basically a configuration that you pass along with the layout when you run the layout. And what yFiles will do is it will use that information to gather, to better understand how the various items should be treated. Let me give you one example. The example that I had with semantics. For example, if your nodes have a certain type associated with it, like email, user, building, team, or whatever, then you would maybe want to tell the algorithms that two nodes are both of type email or user. And you can do this by specifying the node type. And node type is an option, a configuration option that you can pass into. This one takes a binding, and you tell it for each node, basically take a look at the tag and use the type property to understand whether two nodes are of the same type or not. And then you can get a layout like this below, where the yellow ones have the same type and the green ones have the same type. If you had omitted that information, they might have been mixed up altogether. Finally, pass both of these to the layout call, and then this information will be applied. Now, for the last big part, so how do you actually go and start building? There's a few tips that you should be aware of, and some tools that I want to show you. Obviously, we have very good and very extensive documentation, and the documentation contains the developer's guide, which is which is text explaining what I tried to explain to you today in probably much longer form, but in more detail. And there's also tutorials in there. This is accompanied by an API documentation. Every member, every class, every property is documented in the API documentation, and you can look that up in the documentation or use your IDE to look up that information. Those members are mostly accompanied by example source code showing you how to work with these specific APIs. And the API documentation also has usage information. That is, if you find a certain type, you can look up where it's being used in the API, and also in the demos that we have where this API has been used. So use this information if you're unsure how a certain API works. The online documentation also gives you access to our knowledge base, which can be updated in parallel. So it contains frequently asked questions and maybe workarounds for problems others have detected or found with, for example, third-party libraries. The demos, I'm sure you've seen them already. There's more than 300 demos. They contain example applications, but also tutorials. And for all of these demos, the complete source code is included. And most of the source code for the instructional demos is meant to be reused by you. So you can copy over that source code into your application, call the entry method, and get that feature into your application. We try our very best to show the best practices in the demo implementation that we provide to you. So be sure to check out the source code specifically of the simpler demos showing simple, unique features. There's some showcase demos in there too, but there's a lot of application logic in there, and they are not as instructive as the simpler demos. So use the demos as a learning resource and also as a code library for your projects. And if you haven't done so, check out the yFiles dev suite, which is a binary that you can execute via npx, and it helps you manage your demos, search through the demos, scaffold new demos, create copies of them, revert changes, and so on. So check this one out if you haven't already. So what should you copy from the demos? I already gave you some ideas. So for example, check out the patterns that we used for the styling and for the configurations of the algorithms. Feel free to copy those if you like them. Check out the demos, and if you like the behavior, just copy those parts over. Things like configurations for the input modes and the customizations we've been showing there are typically easy to copy over to your applications. Also, for example, how we use the GraphBuilder in there. What you shouldn't be copying is the demo-specific UI framework code, obviously. So these are very simple applications, and your applications probably are more complicated. They use a different infrastructure, a different framework. Our demos typically use no framework at all, except for the framework-specific demos. So be sure to only really use the code in there. Copy what you need, and not the whole application typically. Now this one is new. If you're tired of reading through the documentation, you can also use AI coding assistants to help you with that. We have a so-called MCP tool implemented. It's actually part of the dev suite. This is the way that you can launch it, or the way that an AI coding agent, like the ones over here, can launch it. And then this enables the coding agents to efficiently search through and use the API documentation and developer's guide. This is a really invaluable tool if you're looking for information that is somewhere in the documentation but hard to find, or maybe hard to summarize for you. So use an AI coding agent, give it access to the MCP server that we provide, and ask it questions that can be answered by looking through the documentation, and it will probably come up with very good explanations of the topics. And this MCP agent has access to the source code demos, to snippets, to the documentation, and the developer's guide. So it's really knowledgeable and does only very infrequently hallucinate things because it has access to the actual information. Go and check this one out. It's really helpful. Also, make use of the official yFiles ESLint plugin. If your model hallucinates and comes up with older yFiles code, because many of these models have been trained on older yFiles versions, and they may hallucinate older code or probably code that they haven't been looking at too much, edge cases. The ESLint plugin will help you get rid of most of or many of the hallucinations, and the MCP tool will help the model base its answers on actual facts. If you haven't seen the yFiles Playground, this is something you can try out on our website. It's very easy for trying out something which only requires a few lines of code. And also, if you contact our support team, we will typically reply with a link to a playground that shows the requested feature in action. It's a very simple mini Visual Studio Code instance running right in your browser. No download or sign up is included. And it comes with a pre-configured yFiles application. Just go and write the code. Very easy to test out some features. Once you're done with that, you can actually export the code and download it and start working on the code with a real IDE if you want to. If you're configuring your IDE, then there's actually not much that you need to do as long as your IDE supports TypeScript NPM modules, and that's basically the case for every IDE these days. If you do an NPM install of the yFiles module, your IDE will be able to automatically provide you with code completion, obviously, and also access to the documentation, meaning that even if you do the documentation lookup, you will be able to see some of the source code snippets that we have in our documentation, like in this example over here. And at the bottom, there's also a link to the online documentation, which opens the online browser, where you can read more and see more, get more information for the respective API. Once you're actually in development mode, it might happen that you run into issues, and there's a special development mode of the yFiles library. You will find that in documentation how to enable this one. If it's enabled, yFiles will perform additional checks at runtime, during runtime, and will help you if you're making mistakes. For example, if you're just coding on the console, or if you actually have a runtime error. This will come up with a helpful error message. For example, if the arguments mismatch, you will get a preview of the signature, and you can just click the link and it will open the corresponding line in your IDE. This works via a Vite plugin. So be sure to check that out if you're really working on a larger project. What else do we have? I briefly touched upon the low-code generator. It's online. It's not part of the package. If you want to scaffold your application and you want, for example, to work with a Neo4j application with a React code base, go to the app generator. It will help you scaffold your application and get you started really quickly. There's more projects and blueprints for projects on our GitHub. So check out the github.com /yWorks repository. There's, for example, you will find there a set of React components built on top of the yFiles library that you can use and integrate into your React applications. Those are larger components that would fit into the other demos, and because they are typically specific to a certain framework or integration. But you will find integrations like, as I said, for the various UI frameworks, but also for graph databases and so on. And if you're missing anything, a project or a demo, just ask our support or consultancy team and go to my.yworks.com, where you signed up and downloaded yFiles, and then request support. If you do that, I would like to also I would really like to invite you to test our support personnel. We get a lot of praise for it. So if you have a question, and that's easy to run into a question with this powerful API, is do ask this question in the support, and we'll be more than happy to answer it. If you do it via my.yworks.com, there is the option to request a quick AI answer over here. And if you click this one, it's basically doing similar things like what the MCP tools did before. So it will go and fetch the knowledge base and fetch the information from the API documentation for you and prepare an answer. This works really well for those questions that can be answered by actually looking at the API. So it won't be able to understand your project, and it won't be able to help you with debugging an issue because it's typically not part of the documentation. But for any question that you have regarding this documentation, try out the Request Quick AI Answer button, and you will get an answer within 2 or 3 minutes, basically. And those answers will be reviewed by our team, and if there's a mistake in the answer, we'll be happy to follow up and help you with a correction. That's it, basically. Finally, we did it. What did we cover today? We looked at what yFiles is, what it can do. We looked at the model view controller paradigm. We looked at how the API is structured, the different patterns we're using in the API. We looked at how a simple application looks like, how you load the data, style your items, do the interaction and the layout. And I showed you how to efficiently work with the support material that we provide on our homepage and as part of the package. As always, this is just an introduction, and we didn't really go deep into this. There's a lot more, but I hope this helps you get started with yFiles more quickly than without this help. If there's any questions, please do ask questions in the support forum. Go to my.yworks.com, log in and ask your questions. We'll be happy to help. And if there's anything we can do, just send us an email or a message. So long. Thanks for watching. Happy diagram and have a great day. Goodbye.